So I'm going to get rolling. First, I'm going to start with some background about the Rozalia Project. And when I say we, this is who I'm talking about. We're a nonprofit dedicated to protecting the ocean and the lakes and rivers that feed her. And we have primarily been working on the problem of marine debris. We do that with four strategies. The first is doing data cleanups. So we do cleanups, but we always collect information about what we get in order to prevent it. And then the rest is all prevention. That's prevention by doing education programs, embracing innovation and technology, and doing solutions-based research. We work on the whole water column from the surface to sea floor. So shoreline is easy most places to access, but we also address the surface, and I'll get to our boat in a second. That's a refrigerator floating there. And then I'd like to introduce you to Hector the Collector. That is our ROV, or remotely operated vehicle. That's how we get underwater without throwing anybody overboard. This is what I call ROV face. It is one of my favorite Rozalia Project pictures, and we use that ROV not just to collect or look at marine debris underwater or whatever's underwater, but it is also to connect people to the underwater world right at their feet. So this is what I call ROV face, and everybody makes this face, whatever their age, and this is seeing underwater in real time for the first time. This was actually in Boston, and we had just come across a bicycle. They don't float. We do our work in urban, inland, and coastal waters because that is where the majority of marine debris comes from, and we feel that is the most efficient place for us to focus. We're the team that brought you the Coral Ball. This is a solution to microfiber pollution as it relates to the washing machine. And it goes in your wash, not your dryer, but your wash, to help reduce clothes shedding in the first place, and also to help collect microfiber that would otherwise wash out the drain. We thrive on great partnerships. That's everything from funding partnerships to strategic partnerships and education partnerships to have more people understand these problems through activities and education, and speaking partnerships. I'm one of the I work with the U.S. State Department in the International Speaker Program, and also with National Geographic Society and Lindblad Expeditions. And we're optimistic in the face of an overwhelming problem because we recognize that the collective we made this, and we believe the collective we can get ahead of it. Our research vessel, or our trash hunting mothership, is a sailing oceanographic research vessel called American Promise. And we're particularly proud that we have solar, wind, and hydro to provide pretty much 100% of our house bank power. And here's just a little bit of sailing eye candy for those of you that like to spend your time on Long Island Sound on sailboats. There she goes. I could talk a lot about that, but we got to move on. Rozalia Project is focused on solutions, and this is my kind of working solution flow chart. Our areas of expertise are in the field side of the foundation of understanding a problem, which is doing the science to understand the problem, and then also in education, innovation and redesign, and in science communication. We work on three parts of the marine debris problem: derelict fishing gear, consumer debris, and microplastics. And of course, those are all relevant in Long Island Sound. But it's microplastics that we've been doing most of our focus, and the ones that you can't see, the smallest. We sample the surface of the water primarily and the air. And we've been able to do this work in the Hawaiian archipelago, in Arctic Svalbard, the fjords of Norway, the Shetland Islands, the Faroe Islands, the Falkland Islands, South Georgia, which is pretty spectacular, South Orkney Islands, Antarctica. And I also just had to include this because I love ice and penguins, and they're both there. And there's no bucket picture in that one. The Hudson River, and of course, Long Island Sound. And so this is what I'm going to spend most of my time talking about, is the Long Island Sound study that was published earlier this year. We sampled the whole of the Sound every 3 miles from Brooklyn in the East River to the Race. We use a metal bucket to do our surface sampling, and that's to try to keep contamination to a minimum. We transfer water from the surface, from the bucket to a glass jar. And then we filter that water to on a very, very small filter paper. So we're filtering to 11 microns, which is about a seventh the width of a human hair. So we're looking for quite small particles. From there, we use this incredible tape. It looks like normal tape, but it's special tape that helps us fix whatever was on the sample onto a slide. And so what I'm going to do now is switch over to results. You all have access to this, and there will be a follow-up email. And in that email, I'll make sure that there are some links for you. I'm not covering the background of microplastics, their harm, and that kind of thing in this because of time. But we have some great information of that. And the link to this story map will be there as well. So this is our story map and how we like to share our results outside of peer-reviewed published papers. And so I'll take you through what we found in our really a pilot study of Long Island Sound. So overall, we sampled 29 sample locations from Brooklyn to the race. They were 1 liter each, and we only had one sample that was free of pollution entirely. We are interested in both plastic and non-plastic types of microplastics, mostly because the majority of these microplastics in the study, or microparticles, are microfiber. And microfiber has 2 categories, both plastic and non-plastic. So we're looking for anthropogenic or man-made microparticles. Now, to kind of jump right in and look at this, there's a bunch of numbers, but I want to kind of put it in some context along with some of the other places that we've sampled. So first, considering plastics versus non-plastics, or synthetic versus non-synthetic anthropogenic or man-made microparticles. So this is looking at all of them. And you'll see that Long Island Sound has quite a large percentage of non-synthetic or naturally based anthropogenic microparticles compared to other places that had relatively more synthetics. And I don't have any editorial about this yet. It's something that we're collecting to get a feel for why we are finding so much. It's mostly cotton. It is most likely cotton from clothing, and why we're finding that in higher percentages in some places compared to others. So it was really only for us Hawaii that had more anthropogenic, not plastic, in the samples than Long Island Sound, whereas the more remote places like the Poles and the Hudson River had less. So I don't have anything to say about that yet, but it's something that we're keeping track of. The next item that's interesting to look at is the percentage of fibers versus fragments. Fibers are of the highest concern because in general, we find the vast majority of microparticles are fibers rather than fragments. Now, in Long Island Sound, we have by far the highest percentage of fragments compared to the whole than we do in any of our other samples, with Hudson River coming in second, and everything else a very, very distant third, fourth, and fifth. And I do have something to say about that, which we will get to in a moment. But first, let's look at where we found what we found. So in terms of distribution, this is looking at the overall concentration of particles per liter of water along Long Island Sound. There's a couple gaps you'll see, and that was unfortunate loss of the sample before we were able to analyze it. But you can see here that there are some increases in the microplastic and microfiber where the sound gets narrow. So that's a sort of first observation. The next is we wanted to calculate mathematically where there might be hotspots. The application of understanding hotspots in a particular location would be to do further study in those particular places, because if they are constant hotspots, then that's something to look at as far as fishing, swimming, or other types of recreation goes, that's happening in a place with more microplastics and microfibers, or at the same time to perhaps understand if there's some either source or hydrodynamic mechanism that is causing these places to be hotspots. So we use something called z-scores, which is just looking at standard deviations over the mean. That's explained in here, and you can take a look at that. And we look at primary and secondary hotspots. And we see again that the primary hotspots are really where the sound gets the smallest in terms of width, but it's not necessarily where the sound has the most people. So that's, they're clearly number 112 is near high population area. But there really are more people as you get further into the East River in terms of population density. So we did look at an extrapolation of these hotspots. This is just sort of a heat map as opposed to isolated circles. And then let's look at this population overlay. I like to pile on information all at once. So this gives us a lot. So first of all, you can see the dots. That's results of our study. The bigger and redder, the more we found. And the orange ones are kind of secondary hotspots. Now, looking on the land, the more red and orange, the more people there are. So you can see what we all know to be true, which is far more people at the western end. And we also have overlaid a really great visual that shows ship traffic. We were interested in particular to see if there were any correlations or something to be learned from overlaying ship traffic with our results. And what I think is interesting and something that we are finding in other places is, at least starting with population, is it's not necessarily a given that you find the most microplastic and man-made microfiber where there are the most people. It's the same thing we found on the Hudson River. That is not necessarily the main factor for finding this kind of pollution. So you'll see that the primary amount of people are really just to the west of one of our hotspots, and there's really relatively few people at our other hotspots. So mathematically, those hotspots are similar. One thing that's worth more study is looking at the areas where there's high ferry and recreational traffic, because while we didn't find a hotspot near the Bridgeport ferry, there's a little bit of an increase just to the west. And then certainly there's a fair amount of ferry traffic near our eastern hotspot. So that one, I think there's great opportunity for future study. Remember, this one really is a sort of pilot snapshot type of a study. Okay, so in addition to looking at where we are finding this kind of pollution, it's really important to know what it is if we are going to prevent it. And for us, that means understanding sources. So I'm going to go back and explain something related to our sources. Now, in previous microplastic and microfiber papers, including our own that was done back in 2017, people generally have only reported the color, the material, and the type. And so you hear something like, oh, we found 25 blue polyester fibers. Now, the problem with that is that this microfiber cloth, bathing suits, carpet, and monofilament fishing line, that could all be blue polyester fiber. But you can see, because they are so different, preventing any one of these requires an extremely different strategy than preventing another one of them. And so for us, it is extremely important to go another step in defining what it is that we find. And we are one of the first few papers to add 3 more features, in particular to the fibers. Now, we know that fibers are what we primarily find in this type of what's called grab sampling. And so we can use 6 features of the fiber. So in addition to the color, the material, and the type, meaning fiber, fragment, or film, we are adding shape. So shape of the fiber, it's pretty amazing. Fibers can be square or triangular or cylindrical. The presence or absence and the amount of this additive called delusterant. Delusterant is only relevant with synthetic fibers and it makes them less shiny. So sometimes strategically your carpet or a garment, the designer doesn't want it to actually be shiny. And so they put in this stuff called delusterant and it shows up as little polka dots under the microscope. So it's very easy to see. And then the width. And I will say that looking at these 4 items, it is primarily width and maybe the delusterant shape as well, but primarily width that would help us differentiate between these items. So I'm going to go back to our results. So when we group a microparticle, a fiber will have 6 features and a fragment will have 3. We then give it a category. So we took all of the 88 microparticles that we found on the Long Island Sound study and we grouped them. And we found that there were 30 total categories of the 88 anthropogenic microparticles. Each category represents a potential source. And we're trying to learn what we can do with this type of information. So one is just to kind of say, well, how does that compare to other places? So Long Island Sound is that only in the water. We also did air in some of these other places. But so look on the left grouping, and you'll see that Long Island Sound has a low number compared to other places, but it's really essentially the same as what we found in Hawaii and the Hudson, the 3 places with a fair amount of people. And that is that we found more particles per category. So that would mean fewer overall sources compared to the polar regions where we were finding not very many particles per category. So that would indicate that there are more different individual sources or little bits of each potential thing ending up in the poles. It indicates that perhaps that these more populated places, we are closer to the source. Looking at the specific types that we found more of than others, this is types of particles, there were really only 5 categories that had more than 3 individual particles. So really, it was quite a diverse group of particles that we found in this study. And you can see under description, we found blue, red, and blue and red cotton primarily, some blue fragments and more blue fragments. Some of the fragments we were able to identify as polypropylene. The other ones look exactly the same to the eye, but we weren't able to use instruments to identify them. So they are SNID, which for us is synthetic no ID. And then a colorless polyester that is in the size range of garments. And that brings me to, again, trying to figure out where these likely have come from. Certainly the cottons fit the description of garments, of clothes that we wear. And then we did a little distribution here of materials and widths. And we find that they are primarily in the width range for apparel, for clothing. As far as materials go, that too indicates clothing, with most of those being polyester with a little bit of nylon. Something that we know is that within the world of clothing, a lot of it is synthetic, and the majority of that synthetic clothing is polyester with nylon second place. Here's some of what that looks like. Here's some blue cotton that we found in the samples. So that's probably straight off of a t-shirt. And here's some red cotton. It looks quite natural, but it's man-made dyed. It's dyed with, it's definitely an anthropogenic particle. And then the biggest mystery of our whole Long Island Sound study is this. These are irregularly shaped, but very, very, very small uh, polypropylene fragments. And that said polyester. I'm going to change that. They're actually polypropylene and they're very, very small. These are too small for your eye to see without magnification. And we also found them in the Hudson River. So anyone who has an idea here, bring it on. This is a spectacular opportunity for a capstone project. We can actually get some of these off of the slides to share with people. And right now, our suggested potential items are either potentially blue tarp, but they're very, very, very small. Or someone recently suggested a kind of blue pigment, but we'd have to figure out where it came from to be so ubiquitous. This is the only type of fragment that we found in the Long Island samples. This is it. So real mystery there. Now, we always report on contamination. This is one of the biggest obstacles to doing robust microplastic sampling when you're doing grab samples. And this is where we are using forensic science methods to get ahead of the issue. We take samples of everything that we could accidentally contaminate our samples with. So that means all the clothes everybody's wearing, backpacks, American Promise, the lines, the sails, sail bags, stuff like that, as well as we take air blanks in places where we're processing our samples, whether that's on the boat or in a lab. And then if we find fibers or fragments that match these known potential contaminants, they are considered contamination. And that's how we're able to know this. And we had very nice, relatively low, 27% is quite low contamination for the Long Island Sound study. Now, that's what I have for you here. I can send the paper to anyone. This story map is free and open to the public, and I'll have a link to that. There's lots of opportunities for future study as well, but I'm going to take just the last few minutes here and share some information about our Hudson River because it's attached and I think you'll find it interesting as well. So for the Hudson River, we also sampled every 3 miles. We used American Promise for the majority or the lower half of it up to Albany, and we were accessing it from the shoreline for the rest of the river. We did it twice. Once where we only sampled the surface and once where we sampled the air in 2 places, the water column, the surface, the midwater column, and right above the river floor, as well as the soil. But here we're just looking at water surface heat maps. Now, what was so interesting about our first expedition was that we found no statistically significant difference in concentration across the whole Hudson River. Similar to looking at Long Island Sound, there was no relationship with the fact that New York City is right there. And in fact, we found hotspots or areas of increased accumulation, like where the yellow is, in the alpine regions. And 3 years later, when we went back and used even more sophisticated analysis methods for the samples themselves, we had very similar results in terms of distribution. I think you'll find this interesting as well. So looking at the whole water sample, the water column, we could only have surface, middle, and bottom samples from Albany down. So that's from about 51 to the right. So 51 is Albany and 106 is Ambrose Light, where the Hudson meets the Atlantic Ocean. So looking in that, you'll see there's quite a bit of mixing. It's not like there were microplastics just on the surface. This would be another fascinating addition to another Long Island Sound study because the sound is so hydrodynamically different to the river. It would be fascinating to do that. In the air, we had 2 levels of air samples going, one at my inhalation height, which is about 1.5 meters off the seafloor. My prerogative is PI. And then the other one was up the mast. And again, we found no statistical difference in the amount of microparticles that we were finding in those 2 places. We also sampled the soil and again, did not find any direct relationship with population. There's a big outlier there down at 95 because it was a huge fuzzball. We're just about to submit this paper, so hopefully I can catch you next year on this one. But we looked at a lot of things here, including the relationship with bank characteristics and human use. So for the Hudson, we had 972 pollution particles and 327 categories. For this one, we also were able to look at the categories or potential sources per sample by the sample type, like where we took the sample. And this one was interesting in that the surface, middle, and bottom of the water was pretty similar. The two airs were pretty similar. And we found the most different types of particles in the soil. So that's what that means. The soil for us had more potential sources, and the water and the air had fewer. And I think that makes sense because in order for something to fly around in the air, I imagine, and we don't know what these are exactly, but there clearly needs to be some kind of weight or shape characteristics that allow it to be taken by an air sampler or that allow it to fall out of the sky and sit in the water. We also wanted to know if there were any relationships between what we found in the air with the water and the soil. So that's a good time to bust out a Venn diagram. Remember those? Really useful for looking at this. And we found no relationship between the air and the soil, but we did find the most overlap between the air and the water, which I think is really interesting. And here are all of the types of microparticles that we found that shared two compartments. So let's see, 183 is the one that water and soil shared. That's on the bottom left. That's polyester, most likely from clothing, cylindrical fiber. The rest of it was shared between air and water and is a combination of cotton, fiber from clothing, and those mystery blue fragments. And here's something pretty crazy is the mystery blue fragments were also found in air samples, not just water samples. In terms of contamination, again, in the Hudson, I made a terrible, horrible, no good decision to put the team in organic cotton blue t-shirts. And it turns out that while low priority for the environment, organic cotton does shed quite a bit. So it got all over our samples, and that helped us learn a lesson in wearing something low shed. So I'm going to wrap up with a little bit last information about some of the work that we do. One is called CSI for the Ocean. This is using forensic science methods and methods that we learned on these expeditions on Long Island Sound and in the Hudson to create and push forward a global citizen science microplastic monitoring, mapping and monitoring project that's not just for people this age, but it's for people this age too. We are delivering this program and working with people all around the world, primarily in right now with schools. This is a CSI for the Ocean kit that I just delivered to a dozen plus schools in Hawaii with kids of all ages, but also through the Lindblad expeditions and National Geographic small expedition ships. Then that's how I've gotten to go to some of those amazing places. All of this is in order to protect our precious waterways and to understand in particular the problem of microfiber pollution better. Because doing this kind of geographic work that not just identifies potential hotspots, but also looks deeply at what we are finding can help point to understanding that helps us with solutions. For example, are there places in the world that perhaps because they produce more clothing are regional hotspots or perhaps even point sources? We don't know that until we have more ubiquitous and similar method research. The other question is, and this is more likely to be true, and what our work has indicated so far, is are there more multiple diffuse sources to this problem. And what we need are more resilient textiles, not just in clothing, but in carpets and other types of textile applications. And or can we, should we, and I think the answer to both of those is yes, be supporting the development of better textiles that are ideally bio-derived, so natural on the front end, and bio-benign, which would be not terrible for the environment on the back end. That's our goal. I appreciate very much the opportunity to share this with you. I look forward to some questions at the end and hearing from the next speaker.
Thank you so much. That was very, very interesting, Rachel. I know I see some questions in the chat, but we are going to move on to our next speaker and then we can answer questions at the end. So if you do have questions, please keep them coming in the chat. We will get to them. Our next speaker is Adrienne Esposito. She's the Executive Director for Citizens Campaign for the Environment. And I know that we've been talking really about these microplastics and microfibers, but many of us here on the Zoom know that there are much bigger plastics as well that are polluting Long Island Sound. So I'm going to hand it over to Adrienne, who's going to talk about some solutions for our plastic pollution problems.
Good afternoon, everyone. I'm going to be very quick because I see the questions coming in fast and furious for Rachel. And Rachel, thank you so much for sharing your research and your work with us. It's much appreciated. So, look, plastic pollution, whether it's in plastic bottles, microfibers, shedding of clothing, and much more, is a problem all over our waterways and Long Island Sound. But as you heard from Rachel, it really is a global problem. What can we do? Well, we're going to have to do a lot, and that answer is multifaceted. But I want to say to you, policies work. Next slide. Just as an example, okay, it's a small example with a big meaning. Some of you who are located in Connecticut, New York, remember when we had the famous plastic ban battle? It was the plastic bag ban battle, which is hard to say, but there was a lot of resistance, but we worked with, for instance, recycling municipalities that have the recycling equipment. They gave us all sorts of pictures, as you can see here, of the plastic bags gunking up the equipment and costing them even more money to go in and hand remove them. So they were not only a problem for pollution, they were a problem economically. And that helped our argument. Next. But I wanted to give you the case study. So when Suffolk County, for instance, implemented a 5-cent fee on plastic and paper bags in January of 2018, 1 year later, it was a magnificent and an unexpected impact. I mean, we expected a big impact, but we didn't expect an 80% reduction immediately in that first year, which equated to 1.1 billion less plastic bags. And that's in just one county. So when we went out and did the surveys, we found that almost 63% of the consumers were just bringing their own bag or not bringing a bag at all. So it was really amazing, because when those who go out and pick up all the litter from our beaches, because for some reason we can't seem to put our litter in a secure garbage facility, they were finding less and less plastic bags on the beach, of course. Connecticut put so New York's ban went into effect in 2019. Next. And then Connecticut put in a ban in 2021. So we kind of worked, around Long Island Sound to make sure that it was protected, at least from this type of pollution. Many of you know that these plastic bags were also very harmful to whales and sea turtles and seals, dolphins, who mistake them for jellyfish. And now, actually, we have a lot more, particularly seals and sea turtles and dolphins, visiting Long Island Sound. So who knows how many marine species have been saved. Next. Just wanted to give you the graph. Okay, the graph tells us the reduction in grocery plastic bags. Pink, I don't see pink. Blue is New York and black is Connecticut. Dramatic reductions after the policies were implemented. And I want you to know, when we implemented these policies, it was a little rough. We got hate mail, we got hate email, we got hate phone calls, we got hate snail mail. Um, you know, one person said that, we were like the most hated person on the island right now. We called it the bag apocalypse because people just said things like you're interfering with my rights, because apparently in the Constitution there's a constitutional amendment that guarantees you the right to a plastic bag when you go to the grocery store. So people took a little bit of time to adapt and adjust to this kind of change, but the whole idea was to change behavior. Next slide. Which we did, because it worked. So again, policies matter. The next thing, Melody's trying to make up all those hate emails by a thank you. Thank you, Melody. Municipalities around the country started banning things like straws or straws by request. New York City, kudos to New York City, because they passed both plastic straws by request and also skip the stuff. Simply put, it's a simple bill that when you go to get takeout, you don't automatically get all those utensils and the napkins and the condiment packages that are all in plastic. You have to actually check the little box when you're ordering online, because everyone orders online now, and say, yes, I want them. Not only was this immensely successful, but it saves small businesses and big businesses money, because they don't have to pay for all of those things that we don't need. Now, sadly, Suffolk County attempted to put forth the bill, skip the stuff. Actually, it did. But the legislators there were very concerned. What if I forget to check the box and then I go to the drive-thru and I drive away and I don't have a fork for my takeout and I starve to death in my car? So they abandoned that bill, which is quite odd, but they did. But all of this is to say, in New York City, it's working well. Suffolk County, several years ago in 2020, did pass a ban on plastic straws and stirrers. That's working well. And again, it all adds up. Even when we worked on the plastic straw bill, people mocked it. What is it going to be? You have all this other plastic. That's true. But, the journey of 1,000 steps starts with the first one. I think it's 1,000 miles. It starts with the first step. So even little steps matter. Next slide. The big problem is New York generates, and I don't know what the statistic is in Connecticut, but New York, as an example, 17 million tons of solid waste annually. That's a lot of waste. 40% of that waste is packaging. Plastic containers, plastic film, glass bottles, cardboard. And we only have a recycle rate of 17% statewide. Again, a lot of waste is ending up in litter in communities, plastic pollution in our waterways. A lot of it is burned in trash to energy incinerators, and a lot of it is also still shipped to landfills. I want you to know we use the landfill disposal method when the cavemans walked the earth. They made a pile for their garbage. Apparently, we haven't progressed very much in our solid waste management techniques. Next. It's also a big cost to taxpayers. Why? Because the cost of recycling programs is increasing as the value of recyclable materials decreases. One of the greatest challenges is that the manufacturers and the producers of the packaging material and of all of these boxes of cereals and boxes of, pasta and goods, they have no responsibility for recycling the waste stream that they create. That is a challenge, but that would cause a remarkable change. Next. Many of us in both Connecticut and New York worked on a very important piece of legislation called Packaging Reduction and Recycling Act. It did not pass this year. It hasn't passed for 5 years, although this year We made great progress and we came closer than ever. Simply put, it would put the responsibility for reducing packaging materials and when packaging materials are used, to have them be more recyclable materials. This type of a policy, it's called producer responsibility or extended producer responsibility. For those of you who know the lingo, the inside lingo, it's used in Canada and it's used in Europe. And unfortunately, and states across America are passing it. Oregon, Maine, Colorado, California, they've all passed similar laws. We want to get New York and Connecticut up to speed. It has been quite challenging. Next. One of the benefits of this bill is that would reimburse local municipalities, your village, your city, your town, money to help them pay for waste disposal. So the producers and the manufacturers pay into a fund. The more waste they produce, the more they pay. The less recyclable the material they use, the more they pay. That fund, those funds then go back to local governments to help reduce the tax burden on you and I to dispose of waste materials. Also, many people don't know, for instance, in New York, solid waste disposal accounts for 11% of all the greenhouse gases emitted. So we can reduce solid waste, we can fight climate change, and lower taxes with this legislation. This is just an estimate. This is not given to us. We did not create this. This is what the municipalities gave us. New York City would save $177 million per year. Syracuse, a small but mighty city, would save almost $3 million, and so on and so forth there. Buffalo, $6.58 million. Keep going. Okay. We just wanted you to know that this is a bill, again, that almost did pass the Senate. Thank you to the leadership of Senator Harcum in the Senate. He's the new Senate Encon chair. And Assemblywoman Glick, who did a fantastic job in the Assembly at the very last day, as we were still hanging on. We had enough votes to pass it in the Assembly, but Assembly leadership did not call it up to the Assembly floor for a vote, mostly because the producers and the manufacturers did an effective anti-campaign, falsely claiming that it would cost goods in the grocery store to go up to between $600 and $800 per year in the average person's grocery bill. We know that that is not correct. Analysis have been done in Europe and in Canada where this bill has been in full effect, and there is no verifiable increase in grocery costs. And many producers know that this is the wave of the future, and other states are passing it, and it's going to get done, and they have to conform. But they're putting it off as long as they can. We're going back next year. We're going to try again. But my bottom line to you guys is we don't have all of the solutions yet, whether it's to microfibers. You could take the presentation off, Maureen, whether it's microfibers or whether it's large-scale plastics. But what we do know is reducing plastic matters. We do know that producers and manufacturers have to take some responsibility. And we also know the public would recycle more if recycling was a bit less complicated and a bit easier. This whole system of having the numbers 1 through 7 on the bottom of your plastics, and then municipalities across the state recycle different numbers. So you have to have like a master's degree in plastic recycling. You look at the bottom, you see it's a number 4, and then you have to know if the village or the town or the county that you live in recycles that number. And then sometimes the policies change. So the vast majority where I live, they're taking number 1 and 2 and 5. Although the village I live in takes 1 through 7, but there are other municipalities that only take 1 and 2. Some take 1, 2, 4, and 5, and 7. And that's insane. So we need to make recycling easier and more available to the public. We need better policies. We need corporate buy-in to help us with the solutions. And we need people like Rachael that are going to continue to do this wonderful research so that we can understand better what is causing these challenges. And for the love of all that's good in the universe, I don't understand why still all of these very important beach cleanups are still picking up numerous amounts of trash off of our beaches that are actually many stream areas and parks where people are just not securely throwing out their garbage. It's just a little unconscionable, but we need to do better. So thank you so very much, and we look forward to any questions you may have.
Great. And there's lots of questions here in the chat. So we're going to kick this off. And if you have questions, please put them in the chat because we're monitoring for those questions now. But Rachael, there are some questions here. Did you find any relationship between hotspots and the proximity to treated wastewater outfalls?
That's such a good question. So we in Long Island Sound, we didn't do a perfect analysis on that. We also sampled straight down the middle. So the relative distance that we sampled from wastewater treatment outfalls was pretty significant. However, we did do a specific wastewater treatment plant outfall study that isn't quite published yet, but we sampled at the marked outflow on the chart, as well as 2 miles up current and 2 miles down current of that point at the same exact current. So starting at max ebb in a suburban location on the Hudson at the town of Hudson, that's a rural location on the Hudson at the town of Hudson, a suburban location at Yonkers, and then our urban location was actually on the East River, just right outside the big wastewater treatment plant at Newtown Creek. And so we did look at that, not necessarily in the big picture. We didn't find relationships other than there is a hotspot on the Hudson River near the Poughkeepsie one. It's something that people have been looking at. It's interesting that the wastewater treatment plants generally do an excellent job separating microplastics from the influent so that the effluent coming out generally doesn't have a lot. The problem is in figuring out where it's all going. So a lot of the biosolids end up on fields. And so we know that they're just kind of getting relocated unless the biosolids at a particular wastewater treatment plant are getting incinerated. Yeah, so that's a great question. The good news is that most of our wastewater treatment plants in the Northeast are doing a really good job of separating the microplastics and microfibers out so that the effluent isn't necessarily inundated, but it's still a little bit of a tough big picture because it still may just be getting rerouted.
Great. And actually, Ella had a question. I know Adrienne talked a lot about packaging, and she said she was surprised that you didn't find any particles that come from packaging. And she said, do these tend to exist only in larger pieces?
That's a good feeling about it. I think we would have a hard time. I think that we would have a hard time identifying specific packaging related. We find so few fragments. First of all, a lot of it would be fragments. Little fragments of film like plastic bag or foil, plastic coated, or something like that, like food wrappers. Now, when you go up a level in looking at tows for microplastics, so if you think about it, the definition of microplastics is 5 millimeters or less. But 5 millimeters is sort of big. It's about half the width of your pinky nail. So there's a class of microplastics that are relatively large. You can see them, you can pick them up off of the sand or tow a net and easily get them out of the net. And then there's the class of microplastics that we've been working on, which are less than the width of your hair. So if we go up a level in microplastics, the answer is we did find quite a bit of food wrappers when we did those kind of tows. And we also found quite a few foam spheres. And foam spheres could be released from single-use food packaging made of foam, as well as things like unencapsulated docks and or like the kind of coolers that just don't have any protection, those old foam ones. So the answer is, for us, we don't find a lot in our tiny grab samples, but food packaging in particular is among the most found in shoreline cleanups, and also even it's found a fair amount in larger microplastic studies.
And actually, a good transition. Adrian, this question is for you from Judy Benson. A lot of produce is being wrapped in plastic that could be used, that used to be offered loose. This seems like a good candidate for the campaign for stores to go back to unwrapped items.
I couldn't agree more. I think that would be a great campaign. We're putting it on the list, Judy. No, I think it is a good idea. Listen, I'm not that old. I remember we never had to go to the store and buy your broccoli in saran wrap and buy your even right now they have, those cucumbers are in saran wrap. I don't get it. I
Yeah.
don't exactly. I remember when the transition started to occur, but you're exactly right. It is not necessary. And it would be a good campaign to stop it. And if they had to pay, they meaning the whoever ships it, not ships it, whoever is manufacturing it, they would not use it, but they don't, so they use it.
Yeah, I
So
think it would
that's a
be good
great
for
comment.
I think it would be good for consumers too, because, you don't have to buy six peppers, you could, or, sometimes you
Right. You
can't
could
see, the quality of the
buy your
produce.
one pepper.
Yeah,
Yeah, buy one
yeah, I
pepper,
know.
whatever.
I
Yeah.
agree. I'm kind of a one red pepper kind of person, so I
Yeah.
understand 100%.
Okay, we have time for one more question here. And we'll go back to Rachel. Did you map the landfills for each area? Do you think there's a correlation between the landfills and the microplastic pollution?
We noted that on the Hudson. We didn't map it on Long Island Sound. That would be interesting to go back and have a look. Again, our Long Island Sound samples are smack in the middle, so quite a ways away, though it would be interesting if at the pinch points to look at the proximity of both wastewater treatment plants and landfills. So that's a great thought. Can I quick answer the next question? The what kind of clothes would be considered low shed, and give you guys a little action plan for clothing. You guys clearly are action oriented, so I'll be really quick. So generally it has to do with kind of the weave, and the smoother it is, generally the lower shed. So the fuzzier, the softer it is on your face, generally the higher shed it is, regardless of whether it's plastic or non-plastic fibers. So nice soft cottons do tend to be high shed, as are fleece jackets and things like that. Quick dry clothing, bathing suits, outerwear that's meant to repel the elements, that's not wool, that generally is lower shed. You can actually test it yourself, incredibly, with some very clear packing tape and a piece of white paper. Take your darkest garments and you do it like you're waxing your legs. So take a piece of tape about 7 inches long-ish, put it on the garment. Although if you're worried about it, do it on the inside. Just give it like 3 rubs. You need to do it the same way each time. So like 3, don't be crazy about it. 1, 2, 3, and then rip it off. Again, do it on the inside if you're worried. And then stick it down on the white paper. In many cases, you don't even need a magnifying device like a microscope, or you could just use your phones. Goes to, I think, 10 times. You'll be able to see if there are fibers. Again, use a dark color on white paper, and you'll be able to see and get a feel for it. And so for strategies about that, since doing this, I didn't throw my fleece away. I don't think you should throw fleece that you already own away. It still can use some thermal good. However, I do tend to wear my fleece underneath low shed thing when I go outside now. So instead of it just kind of pouring out into the environment, it's protected. I'm not letting it go to landfill. It still has a use, but I'm being more strategic. In the big picture, washing less often. So only like this I would tell your children, that if you wear a garment between like dinner, bath, and bedtime, and as long as you don't drool on it, it's probably not dirty and doesn't need to be washed. That is good for the planet. Spot clean when you can. Wash in cold water. 3/4 to full loads cause less shedding. So that's a good one to remember for the family. Also, less overall work to have full loads. If you still have a top loader and are getting ready to replace it, replacing with a front loader makes an extremely significant difference in terms of shed. And remember that when you lower the shed rate through these techniques, not only are you protecting the environment, but you're also making your clothing last longer. And that is just all good all the way around. So yeah, we'll leave it at that since it's 1:30 right now.
Well, thank you so much to our speakers. I'm going to hand it over to Holly to close us out. We really appreciate everyone joining us.
I want to say exactly the same thing, Maureen. Thank you to everyone for these wonderful presentations. And just a reminder that the Long Island Sound Coastal Watershed Network is really focused on bringing people together to hear this kind of research and talk about these types of solutions. And I want to make sure everyone knows that we're collecting all of the questions and we're going to share those out like we discussed earlier through our email system. So make sure you're signed up for the network, invite your friends to sign up for the network. And Rachel, we'd really like to have those actionable items that we can share out. I think those are exactly right. Those are the kinds of things that this group is really focused on. So many thanks to everyone. Enjoy your summer on Long Island Sound, and we'll see you in the fall with more events and the opportunities to get together and work on these projects.
Thank you,
Thanks,
everyone.
everyone.